Hello, everyone, and welcome to our What's New in Terrasolid version 21 webinar. My name is Matthew Stevens, and I will be moderating the presentation today. At this time, I would like to go ahead and do an audio check. Please notice the raise your hand button has been circled in red on the slide. And if you can hear me, please click on this button now. All right, looks like everybody can hear me. Group audio has been disabled for this session. If you would like to ask a question, please use the question box on your GoToWebinar panel, and we welcome feedback, so please feel free to leave comments here as well. If we don't get to your question during the webinar, we're going to follow up afterwards with an email response. So just keep that in mind. And this webinar is scheduled for 60 minutes. Presentation today is going to be led by Derek Wagg. He's our support director. Of course, I just introduced myself a second ago. I'm Matthew Stevens, and I'm a support associate here at GOQ. We support a lot of different software and hardware products. Today we'll be focusing on the Terrasolid suite of software, and I'm just going to go ahead and hand the webinar off to Derek and get started. We got a lot of stuff to cover, so handing off to you now, Derek.
All right, thanks, Matt. All right, you should see my presentation here on the Terrasolid family of products. Matt, you see my screen and hear me okay?
Yep, I can see your screen and hear you just fine.
Great, perfect. All right, so just to give you a brief overview before we dive into kind of all the new features and changes, we'll just talk about the Terrasolid family product that we support here in North America. And we head up all their support and training for a very large number of their customers here in North America. Of course, this webinar is open to anybody interested in the product, so they may not have that much information on the different modules that are available. So there's just start with a little summary here. There are several different products that Terrasolid does produce, and we mainly support 6 or 7 of them that are focused on primarily point cloud processing. We originally started off as LIDAR processing, and that's kind of expanded out as we're seeing more and more photometric points and other types of point clouds that people are working with. The typical workflow we see usually involve these various products, starting from survey, being able to bring in some ground control or other various collected data surveyors are doing, some geometric matching, then with TerraMatch, and then the main module, which is TerraScan, which is the point cloud processing engine that has a whole bunch of different things that it can do and help you do with the point cloud data. The TerraModeler module, which adds all of the surface capabilities to the products, and then the TerraPhoto module, which adds anything to do with imagery. So that adds a bunch of different workflows that you could do when you've got co-acquired imagery or orthophotos to go with your processing. So TerraScan has a number of algorithms that are specifically aimed at point cloud processing. There are specific algorithms for airborne and mobile processing. There are some things in the product for terrestrial tripod scanners. There are some algorithms in there that are specifically aimed at photogrammetric point clouds. And then there are also things in there for various systems like backpack scanner systems, handheld scanner systems. So there's a pretty wide array of algorithms for doing various types of things with the data set, from classification, vectorization, analysis, information extraction, any of those point clouds, and a lot of those algorithms are usable across the different types. TerraModeler is what adds in anything that you want to do with surfaces. TerraModeler also has its origins in giving you tools to make working with vector elements and things in MicroStation a little bit easier. So there are different tools in there just for working with that, and working with trying to generate different types of products from your surface information. TerraMatch is the module that adds all the algorithms for manipulating mobile and airborne laser scanning data. There are some similar algorithms for modifying photogrammetric point cloud data in TerraScan itself, but TerraMatch is geared more for making the adjustments and corrections for trajectory issues and placement issues for airborne and mobile laser scanning data. TerraPhoto is the package that allows the suite of products to work with imagery, whether that's raw images that can be used for reviewing your point cloud, it could be coloring your point cloud, doing things like pulling up the image that best sees features in your point cloud. There's a whole bunch of different things here, and then all the way through kind of the traditional production of ortho mosaic off of aerial imagery, also off of things like the backward looking pavement camera for mobile data or UAV data sets, and then also can get into full point cloud colorizations as well, where you actually colorize the raw point cloud and have a lot of manipulation tools available for you for picking out what images, what color changes, seam lines, everything else like that to use even in those scenarios. TerraStereo is the package that allows you to view very large numbers of points in a point cloud. There's some direct connections that you can take from a TerraScan project to configuring a TerraStereo project, and it just serves up the information in a little bit different way that allows for some very large point cloud visualization. That can be done both in a mono view, but it's mainly aimed at setting up for stereo. Stereo then adds the ability to do feature collection off of your data, and you can do this in MicroStation Connect Edition. You've got the appropriate video cards that can support that kind of functionality. And TerraSurvey is the additional piece that a few users use to just help bring in survey collected data from total station GPS units that traditional surveyors are using, and some of those data sets, and bring them in and creating a 3D CAD model out of that. It's quite a variety of applications for point cloud information, and TerraScan plays in all these realms in at least some capacity, and usually it's to help configure up the survey information, the mapping information, and get it configured for analysis and things like that. It's certainly not limited to this list of applications. A number of other applications are also there. So we're going to cover through today looking at the basically what's new in Terrasolid. The version 21 products just came out a couple of weeks ago now, maybe going on 3 or 4 weeks ago now, I guess, because we're on our fourth release of the version 21 TerraScan already. TerraSolid operates a little bit different than the traditional, or even the way we do it at GeoQ. We typically you see like a major release, and with that major release comes hundreds of new features. TerraSolid made 34 releases of TerraScan last year. That's almost a release, a little better than every other week. And those releases are done on the basis of incremental changes. So it gets the changes, the new features into the hands of users as quick as they can. make things available, make fixes available to you as soon as they've been implemented. So you often see quite often the changes are done. So when we talk about what's new in the version 21 software, we're really talking about what's new in the products, what's been introduced or modified with the products over the past year. So we did a webinar like this back at the end of January of 2020. And so today's webinar will kind of cover off and try to highlight a number of the different features and different changes that have occurred since then. You'll find on our searchable support knowledge base, that's at support.guq.com. This is a really useful place to go if you're looking for information on the products, looking for hints and tips on workflows, ideas and tips on error messages and when things aren't working. We keep trying to add and expand out this information base here, so that's available to all our users and hopefully helps everybody accomplish what they're needing to do. I have posted up on here some presentations. I'll cover some of the features in these presentations today. So they are available for download on the site now if you're looking for something to link into and follow along with. We are recording this, so you will get a link at the end with the link to the recording, and we will also post a link on this page here, where right now it's got the registration page for this webinar that we're currently doing. So you have a couple spots and ability to kind of review back what's going on. Of course, at any point, feel free to interrupt me. There's the group audio is disabled, but you can certainly ask questions, and we'll be paying attention there, and I'll try to answer what we can. Whatever we don't get to, we will get to afterwards. So some of the features that have been done. So if we look at like TerraPhoto, there's a number of incremental changes, a number of format changes and things that have been implemented, some extra support in there for accuracy information, and some changes along the how panoramic images can be used. I'm not going to dive into too much detail on those. In TerraMatch, again, there were a number of incremental changes over the past year, and probably the one of the biggest changes that occurred is in the fine fluctuations. There is a new option called Smooth Curve, and the old option has been changed to Restricted Curve. So Restricted Curve is where you use the trajectory accuracy that's associated with the trajectory. So you do need the accuracy information in there, or you need to have set it. So there's been a few different things added into the product for being able to set and adjust those accuracy values. And then you can use those to limit the rate of change. And that's the one that anybody that's been using the fine tie line fluctuations tool has been used to. That's what's been in there for a while. And then this new option was added, which is why the old one was renamed a little bit. And it's called a Smooth Curve. And that uses a 1D Gaussian smoothing. So it's very useful with data sets where the adjustment that you need to make is not really dependent on the trajectory accuracy information. And this will occur if there's a lot of stops or slowdowns in the mobile data collection, then this can become a handy new option to utilize. In TerraModeler, again, we're several small improvements with support for some new TIN models, an inframodel format, a couple other little changes. The big change that I think a lot of users will encounter once they put on this week's build is there's a change in the way preview contours work. If you've used the display shaded model, then you'll see this new option in here. And when you display your contours now, it's changed to where we use views like you set up in your display shaded surface. And this was done because there were problems. The old method used levels. In fact, typically, if you go way back, traditionally that was on level 49 was kind of the default back in the old 32-bit software. And we were finding that there were several design files that for some reason or another wouldn't allow the software to display through that mechanism. So it got rid of the level idea. The preview contours are virtual elements. They get drawn into the display by TerraModeler. They're not actually in there. You can't click on them, and they're not an element in MicroStation itself. So give you this view option instead. You pick which view you want to display those in. It does still have options underneath the contour options for setting your style, your symbology to use for display. There's just no level number on here anymore, and it allows for those contours to then quickly display on the data set. That was just in this week's release of TerraModeler. So if you haven't updated it, you haven't seen that change, but be aware that that is in there when you do make the update. The other tool, which is a tool that I've been wanting for a while, and I'll show you an example of this. And this is a Smoothen linear element. And we do show an example of the new top of rail extraction. I'll show you where the feature that gets extracted by TerraScan, and we see this in other use cases such as extracting automatic extraction of curves, that they tend to fluctuate a lot as the data does, and so they're a little bit noisy, and people like them to be a little bit smoother. So this new tool in TerraModeler, Smoothen linear element, will allow you to smoothen the vertices when you have a high rate of vertices on an entity, where you can average looking at a certain distance forward and back from the vertex to make a determination of any adjustment to make, and that can be done in X, Y, or it can be done in X, Y, Z. So you have a few options for how to apply that smoothing. It is looking at that point only at the element itself, not looking at the point data anymore. But there's some uses for it, and there's some additional methodologies as well, where you can add in additional vertices and give it some B-spline curvature. So you've got a couple other options depending on what you're trying to do with these elements. Like I said, I'll show you a little bit of that after a bit. So in the in TerraScan is the primary module, for point cloud processing, and TerraScan is where we generally see the most number of updates and changes over the course of the year. There have been several changes with some format changes and some small little changes to different tools. Yes, there have been some speed improvements, particular to the ground classification routines, both the hard surface and the standard airborne or axles and algorithm ground routine. A few other little tools to help with different information. So one of the big things there is there's been additional support for Regal's extra byte information, which is adding deviation and reflectance. And you can bring those in, and it's recognized by the different products now, and you can pull those in different tools and bring those across. Been increasing the number of fields available in the user point formats, which has been good because we've been having some you're running into some things in the UAV space where sometimes you're getting out of fields and you're having to reformat and stuff to get it in TerraScan. So some of the changes there will help with that. Oh, way too far. Try that again. There's been a few tool fixes, kind of small changes in the group tools. The group tools have been proving very useful for data analysis. And part of that is the inspect group tools where, to get a little bit better on the analysis, if you're trying to do something like counting the trees on a site, then you have to do a little modification and fix up of the groups themselves. And so there's a new section alignment there, which actually aligns with the shape of the group, makes things a little bit easier to clean things up. Also finding often the need to, where people want each feature written out as its own file. So there's a new tool for doing that. And a modification in the assign groups is in the group by density, you've got now access to what was behind the scenes as a fixed gap. Now you can set that gap distance yourself. This can be quite handy when you're trying to get objects to group together as a single object. So say you have a pole and maybe the cross arm is a little bit disconnected from the main pole structure in the point cloud. And so you're getting two separate groups, and then as two groups, it doesn't look like a pole anymore because in the classification side, the software is looking for a pole with a cross arm. Then this will give you a way to adjust the setting and reach out a little bit more and grab that so those groups get grouped together. So you get a little more control over how that grouping occurs. Basically across TerraScan, TerraModeler, and TerraPhoto, TerraMatch and TerraPhoto and TerraScan. Part of the big change last year, or really over the past couple years, has been moving away from the old MDL style dialogues, and that has allowed for the software to be in multiple CAD packages now, so you're not just restricted to Bentley. You can have it in the Spadix CAD package. And so one of the things that comes out of that is they've moved to kind of standard Microsoft Windows, and those allow for resizing. And so we're starting to see some of that functionality start to become visible across the product, and on several of the dialogues, you can start using the scroll wheel and resize that without having to just use a view menu anymore to do that. So that's making things a little bit nicer to work with. And we'll see continued improvements to that. That process is not done. It's just kind of happening slowly as we go along with things. There is a new cloud type setting, and this setting, it used to be a setting that didn't really do anything, and this year it got, the past year here, it got changed and introduced, and this is now used, and it can affect the optimization for routines that are run. This is where you tell it, I've got airborne LIDAR, I've got mobile LIDAR, whatever the case may be. So it's important to set that information. It can be set when you're reading points. It can be set on your project information, and it can be set, it can be modified in your main point window as well. So there's a few different spots for that. There's a few display changes. So there's been a few new display modes added. Let me just get rid of my contours here. So one of the new display modes that was added in was to look at the normal. There's always been a normal plus intensity, and normal and intensity shades using the normal vector, so you can compute in TerraScan the normal vector, and you can store that if you're processing in the TerraScan fast binary format, the FBI format. So that's been in there for a while, where anything that is non-planar gets colorized with the intensity, and the rest get the normal displayed. The normal itself on its own was introduced, and that'll show the normal. So this allows for seeing a little bit more of the complexities in building roof structures and terrain. Looking at that normal, where that normal then is going to be, especially when you think of it as a planar feature, your normal is going to be perpendicular to that plane, right? So you're 90 degrees to that plane. There's a time coloration where we do time off of both time and then of course you can modulate with intensity as well. This is introduced really handy for like handheld scanners, telling where scanners are, which way things are going. With airborne data, I find it really useful if I've got airborne data, especially if it hasn't been separated by point source ID, which tends to be the case with a lot of UAV data sets, and I can figure out whether I'm looking at just one collection or multiple collections by the user-defined setting here of a separation in time. So there's a couple options in here. Another one that was added in is scan direction. Scan direction with a rotating prism. It's just going to tell you is everything in one direction. Scan direction with a oscillating mirror system. As long as the LAS data has been properly formatted, where it's got an edge of scan flag, then you'll be able to tell positive and negative direction of those scan lines, which can be helpful for quality analysis and doing some troubleshooting on systems. The other display method that was introduced is density, and coloring by density is really a very useful tool when it comes to terrestrial or tripod laser scanner systems. This was this image here is from a scan setup. I think there were 45 scan setups or something that they did in this project. And once you start to get a lot of overlapping ones, it can be difficult to tell where the scans were taken from. And this color by density has been proven useful for helping to see where each of the scan setups are, because there's a real high density right around the tripod scanner. And we can use that for verifying things, like making sure that we've got all the different setups, that we got a control point for each of those, because if we know the location of the scan setup, there are a number of tools that we can make use of within the Terrasolid products, by creating a trajectory point for that data. With airborne laser scanner data, I've found this useful for evaluating point density changes along a flight line. When the aircraft pitches back on itself and you get double or triple density, in some cases in UAV data sets, this can help see where that is. It can also be helpful for just looking at side lap between data sets. So I've found a number of different uses over the last few months where this has just become a handy tool to look at. Probably the biggest change from a productivity standpoint was a complete rewrite of the way that the TerraSlave module works. So if you're not familiar, TerraSlave is a module that comes with TerraScan. It is something you can run on your same machine as your TerraScan with your TerraScan license. TerraSlave is the way that you can also do some basic distributed processing, where it's not extremely intelligent in terms of the way it tells you errors and handles things back. Got our GQ command dispatch system that does a much better job of handling that kind of information. So if you're doing a lot of processing, that's the better way to go. But for some just minor or local processing, this TerraSlave TerraDispatchers is a good tool to use. I typically run all my macros using TerraSlave that I can, simply because I've got a little bit better interaction to be able to stop and restart the macro if there are problems that are encountered or that I see in the data set. So this change to the TerraSlave using a TerraDispatcher has given some other functionality that we can do. Not every algorithm in the product is the same. Some of them are multi-threaded, some of them are not. So there's a setting in TerraScan that allows you to set the number of threads. And what TerraDispatcher allows you to do is control the number of instances. And there's a really nice tutorial that the lead developer at Terrasolid put together. And find that on our knowledge base, and it'll take you through there, and it basically shows you how you can modify the instances. So, if you're doing some functions that don't require a lot of processing, you can ramp up the number of instances of that function that are running on a machine. Try to take better use of your resources. The biggest caution there is, it's one thing to run into a problem with the overclocking, overuse of your CPU. Another thing, if you do that with memory, then you start writing the disk, and that severely slows things down. So you always want to make sure that you steer clear of maxing out your memory usage. So TerraSlave, TerraDispatcher, that was introduced back in March of 2020. So hopefully everybody's using that by now in at least some capacity. So a change that doesn't really make a difference for airborne classification of ground, but it does make a big difference in photometric point clouds, is the addition of a use of the vegetation index as a probability weighting. The reason it's not as much of the reason you don't use it in typical airborne processing is that in airborne you tend to have separation between features. In photometric point clouds, everything ramps as it goes, and it makes it much more difficult for the algorithm to be able to see what is going on and where there is ground versus where you've got vegetation. So things just kind of ramp from one into the other. In these point clouds, then we've got a lot of color information. They come from photometric point clouds, so they are derived off of the imagery. So there's an RGB associated with that. A couple years back now, it was introduced into the product, the ability that when you have RGB values, then you can look at things by vegetation index. Vegetation index uses a setting in the TerraScan point display where you set the limit of where that visual band difference happens. So you can modify that in a data set and figure out what value then can be used to help better represent what is ground and what is non-ground. So you see here the green is going to be the vegetation, whether that's some lower veg, some small bushes, trees, and then your man-made features, right? It would be more the gray, that's your ground, your man-made features, things like that, right? So what you could do that is, the distance attribute that's been kind of ever expanding in its use and capability. You would kind of go through the standard processing that we do for a photometric point cloud, and we've inserted in then a couple new steps, and that is after we do that hard surface classification, you compute the distance based on the visual band difference, and you set that limit in there based on what you determine for the data set as a good value. Then the distance value is a computation of whether something's, that index value, right? So we're computing the index value and we're putting it in the distance attribute. Because it's coming off of color, that color is a little bit noisy. And so we want to smoothen that. We have an option. Can't remember when this was, I think it was introduced a few years ago for some mobile coloring processes. There is an option to smoothen color. but we would prefer to smoothen the distance in this case, so we were going to smoothen the derived value as opposed to smoothen the original colors. And we run that by looking at a radius around each point, and then taking a maximum number of points within that radius to use the coloring from, so that we can smooth the rating. With the with the distance, of course, there's been a lot of change to how you can visualize the distance. I think I skipped over that. One of those, let me just switch back to this one for a second, just because I've got this one already colored by distance above ground. One of the changes we saw here was a transition away from kind of the standard MicroStation color table to using these smooth transition colors. And I generally, set a bunch of these different ones up and save out those color tables. So I've got a number of different color tables saved for different processes that we typically run. And you can then visualize. So in this case here, I've done the distance as it's been computed as a height above ground, right? What's the height of each point to the ground class? And so we can colorize that up and pick and choose, what goes in there, and then we can modulate that with the intensity. We can say, anything below these values or within this value range gets colored by intensity instead. So I can get, where I'm not coloring the points that are really just my noisy ground points. I'm seeing the features. So you can see this is our new office under construction, and you see all the construction vehicles around it. So if you look at that then from the perspective of we've computed the visible distance index, or the visible index as a distance, then we can construct in here values to use. So we can color up I've got the right one. And you choose, what colors you want to use and what value ranges you want. So I've set these up so that I'm using that difference there that we had configured in the data set. So then we can see the vegetation index. You can see that the light blue, really the blues, all represent the man-made features. The reds are going to be, definite vegetation. And then you've got a couple other, the other color ranges, the definite vegetation. Then you've got the reds on the opposite end. It's more likely to be just a low vegetation type of deal. So we can take that then and utilize that information in the ground class by setting a rating. The more we want to use or rely on the vegetation index to tell us whether it's ground or not, we can adjust that. It's just a sliding from 1 to 100. 100 says rely heavily on that distance, and 1 means don't use it pretty much at all. And that can be then used for figuring out, for determining whether something is classified as ground or not. When you run that then on this data set, and this is the HIPPO's data set, if anybody's worked with that one in some of our training material. I'm gonna look for here, display mode. When we run this, then we'll see that our classification, gets a lot better. We don't pick up the class, where we don't pick up, doesn't go up under the mounds. And if we compare that to, I'm going to read in the same data set classified without using that distance weighting. And I've just put the ground from that data set into class 19. And then you'll see how, when this finishes loading in here, you'll see the difference of how it, where it classified some features before, because it was able to, work its way or ramp its way up off of, what would be the ground. And because of the way that that data set works, it kind of ramps its way in. It's taking so long to load. And I will show you if we take advantage of coloring. I'm going to change the computed distance here from the visual band difference, where I'm going to compute between classes, where I'm going to compute the difference between the class 19, which is my traditional without the veg index ground, and then my class 2, which is with the index. And I'm going to use that then to compare the two surfaces. So I'm going to color up the color setting that makes more sense for surfaces, and I'm going to ignore anything that has less than a 5 centimeter plus or minus difference on it by coloring it veg. And I've got 19 turned off. Okay, now I've got I'm not sure what I just messed up on my coloring, but you can see the gray features here. They were supposed to show up. Here's the gray features. You can see here, they ended up with some ground classification on them. And with using that vegetation index, we were able to avoid that in the data set. So that's just a change in that photogrammetric workflow, where we changed to adding in, doing a computation of that distance value as from the visual difference, and then use that in the rating. That's one change. There's a change and a number of improvements in synthetic point. Synthetic point used to be, you could only take and add in a single point. And so often we were seeing users that were doing this where they would want to put a point in at the attachment. So a couple changes that occurred here. So in the Add Synthetic Point tool, you have now options for how you add that point in. One is you can do selected polygons. This is useful if you need to add points into an area, like say you have a water feature and you want to create points that represent that water surface. Then you can quickly add synthetic points in to do that from your polygons, and you have a number of different ways for how to add in elevation for those points. For some of the power line workflows that I've seen users doing, you can add synthetic points along the vector element. You can do that at a spacing where maybe I want to point every 5 meters along here, or if you pick something like on par with a large spacing, then when you run this, it's going to give me a synthetic point at each endpoint. My computer is struggling today. It's not the software, it's my computer. It's on its last legs. I'm waiting for a new one to arrive. So we see I've created points, and we've now got a synthetic point, and that synthetic point will be at the endpoint. So if you've used the vector routines to vectorize your catenaries, and you go through kind of the standard vectorization process, that helps you really make sure that those catenaries are placed and in the right location, and you've done your attachment adjustments to it. Then you can take those resulting elements and now very quickly turn them into synthetic points. If you need those synthetic, if you're not really looking for them as synthetic points, which is the case in some workflows, you always have the ability to write those points into the design file as well. So it gives you a way to convert some of these lines into vector element, or sorry, into point features as well. So there's a few different workflows where this could become handy to use. There's a number of different ways to create projects and project blocks. Different tools for doing that off of design block boundaries, for creating in your, this one here, in your projects, you've got the ability to create along center lines, tower strings, things like that. So a new one that was added for mobile mapping allows you to create project blocks by just utilizing the trajectory information. And a change here that affects aerial as well, just simply because there's a change in the cut turnarounds tool. The cut turnarounds tool, if I read it, let me just show that trajectory. That trajectory, for this very complex project looks like this. So there's not kind of a quick and simple way using what we used to have in the tools. The cut turnarounds originally was designed to look for the teardrop shape. And now that we've got other types of systems, we don't always have that nice traditional airborne teardrop shape. So it's been modified so we can play with the settings a little bit to determine how best to cut the trajectories. And if I do that, I'll draw these into the design file so that we can see them. And I can explain just a little bit of the difference. What it's doing is it's looking for this, where we've got turnarounds, it's looking for where we hit the separation, and then it's using that to find a cut point. So the setting in there, in the cut turnarounds, there's now settings where it actually allows you to, decide what's the length of line to keep, what's the separation between, or your spacing your line. So I've seen this now where I can take a UAV data set that has continuous collection of the data, so I can't use the split by data gaps or in the laser gaps. So I can use this cut turnarounds now to cut out those box turns or those things that are closer to box turns that we see in some of the UAV data sets. So once we have our trajectory then for the mobile, we can use that trajectory by creating a mobile project. Uses the trajectory, and then create our blocks along the trajectories. Let me make sure I pick a new level for the blocks to go on. So we do block, create along trajectories. And like the other create blocks commands, what this does is you pick your settings of how you want the blocks done. This is along the driving interval, and then it will create blocks. So it's created some nice blocks. We can, of course, go in and we can modify these. We could use the design block boundaries tool if you wanted to adjust those for point counts, if you brought in your overview. So you can do all kinds of the adjustments of everything. And then once you're happy with all that adjustments, if you then just select your elements on the level and use those to add by block boundaries to get in your project blocks into your project. All right, so just another way, another tool that can be used for quickly setting up some of those projects. Number of different improvements in the geometry side for vectorizing buildings, for doing full 3D vector models. There's improvements in the building vectorization process, some new tools in checking the footprint polygons, things like that. So there's a number of different things here. Finding the centroid from polygons that fall within the bounding polygon things. So there's some different ways to utilize that. There's a new tool in the project where you can export. This is useful for publishing your point cloud into Google Maps. There's some new settings on the moving objects, which allow us to look at, to actually have, this limit and require was always there. It was just hidden. And now we have control over it. So it allows us to do some things where we can modify these settings so that we can get things like fences so that they don't get removed as moving objects just because they have, pulses that move through them. So we can change these settings around to get get a better results from the moving objects, mobile data sets. There's a new workflow for finding the road bumps and potholes. And Archie did a very nice little tutorial on this, which will take you through colorizing. So it's a new distance coloring routine or distance routine. And two things that came out of this, one is a new computation of distance, and the second is in the export raster images, you have the ability to create rasters using the distance. So that gives you a number of different options, especially on the analysis side, because you can colorize, and use distance to represent a number of different pieces of information. You got now a way of rasterizing that as well. New tool on the View Laser toolbar is the Measure Coverage tool. Allows you to measure how much of a certain feature types in an area. So my little example here, I've got this block of data, and I just want to see how much of the block is covered by building points. And so I found that in this block there's 12% of the block that's got a building on it. Various other tools usage. Big change on the rail side is the Find Rails tool. Always had the ability, what was introduced for mobile data, and you can construct rail section templates to look at the data and see how best we could fit, how best it fits to the template, and does a probability matching to determine. Well, with airborne data, we don't really get a good definition of the shape of the rail, but we do get top hits. So we can use a couple of new routines that were added in. One is in the Find Rails is a new algorithm for finding the rails in an airborne data set using the top hits. This works with, a lot of these rail data sets now are much denser than they used to be way back, and so this helps with it. We also use a new option in the thin points routine where we try to find the highest hits in an area, and that helps with the extraction piece here. So if I look at a data set, this is a data set from Nebula Partners, which is a Terrasolid reseller in Germany, and happens to be a LP360 reseller for us there as well. So this is a rail data set. Various other things are in here. And if I get a little bit exaggerated, I probably don't want it there. Look somewhere that's not on the bridge. It's a little bit nicer to look at. Then we can see there is a number of hits. So this is done the ground classification in here. Once we've got the ground classification, then we've used the compute distance by height above ground to assign a value to those points. Am I not showing? I have to check. Yeah, I didn't save it in that one. Let me just switch data sets here real quick to one that's a little bit smaller in size. So I can run this before we run out of time. Same data set, just a small section of it. So the concept is we take the, some rough alignment of the tracks. We use it to do a classification by center line to identify the potential rail, the points that are within the track area. That's kind of how they're referred to on here. If we look at the points on their own, we can start to see there's different features in here. You can use some different tools if you need to clean this up a little bit more. There's some, do things like looking at close point points, things like that. This is basically just taking our points that are within a quarter meter of the ground, and then within, an XY distance of the alignment, and put them into this potential track class. We have a lot of points right here. There's a big cluster of points, so we want to thin those out. And so we'll use the new option in thin points, which allows us to keep the highest point. That moves all but the highest points out of the potential rail class. That cleans up, and now we start to see these a little bit better. If we then use the road and rail tool to find rails, we run that on this track area class using the rail top hits. That's the new option that's been added, that rail top hits algorithm. You give it the track width, approximate track width, some minimum length of distance you're looking for. I want to find tracks that are parallel, and I can give it a tolerance for that off of the data set. It's going to put into the active symbology the points, or sorry, the vector elements. I didn't color it, didn't do those. You'll see that the vector elements have some wander to them. They're not the smoothest elements that are extracted, but we have that new tool in TerraModeler, which is Smoothen Linear Element, which is useful, like I said, in a variety of different extracted features. And we can smoothen. There's different options here for adding vertices to the element, either by the spacing or the turn. Get better splines in place. We do X, Y, and look some distance back and forth on there. And we just pick I always forget that I have to uncheck this guy first, or I'm going to end up smoothing him. So let me do that. Now I can pick the element I want to smooth, and I just select them and accept them. And you'll see that it is smoothing out those vectors. So you have some options in how you do that. Over here I had some other ones. Some of these are, well, not that smooth. We run that smoother, we get a much better smoothness on the line. Right. So this can become a handy tool. Right. We can change settings if we don't like what it did. And then we might want to add in some vertices in the angles. Right, so you've got a few different settings in there. So that's the fine rails using top rail hits, and then the new setting in thin points, and the new setting in the new tool in TerraModeler, Smoothing Linear Elements. All right, so I'm running close on time, but certainly open to questions. That is our, a lot of the new features that have been added into the data set. You can find a little more detail to them. You'll see in the presentations, there's links to several tutorials. There'll be more of them going up that try to walk you through some workflows that utilize these new tools, and walk you through some of the changes that they can introduce into your current workflows. Certainly there is, certainly we're open. Typically spend a lot of time on the road doing on-site training with users. But of course, with everything going on around the world right now, that's we've kind of just doing an online format for the time being and trying to help users out. So if you've got any questions, you can contact us. support@geoq.com is a good email address to use. Matt, you got the slide there. And then, if you're not one of our customers, you feel to contact us. Terrasolid@geoq.com is a good spot to go. A few questions. There is Terrasolid is doing a lot of investigating at different ways of doing AI filtering on data sets. There's one option in the data set that was introduced a couple years ago. It's called object detection. Can be used for finding poles, finding and vectorizing poles of various types. That's in there. They are trying to come up with some various ways of doing some other things, run into some problems with a variety of training data sets, and then how just some of the features change so much depending on where you are in the world that it's, and even some cases very locally within the world, that it's seems to be slowing down progress on that side a little bit. But the we have filed, somebody asked about the support for LAZ 1.4. It's the newer LAZ compression format that was introduced, and that's not been incorporated yet in the Terrasolid tools. I know it's on their list, but I don't know where it falls in their priority of things at the moment. We've got support for all the other LAZ formats, so they haven't really bothered to go to the new one yet. There's a that weighted distance tool that I showed you for looking at the vegetation index seems to do a really good job. If you get the right percentage, you have to adjust it a little bit with each data set, but it does a good job of distinguishing differences between bush versus low grass areas, so that you get ground where you've got manicured lawns, even though that would be green and come up as vegetation. It gives you ways to kind of look at that. So it does a pretty good job of that. There's a number of other questions here. We've ran over the top of the hour, trying to highlight all the different things that have been added in. As you can see, there's lots of new features, lots more coming. You can expect to see a number of new features this year, improvements to the workflows, new tools for analysis, new tools for trying to help you out with the various things. If you got anything that's specific you're looking for, feel free to hit us up. If you need training on any of the new features, need to be brought up to speed on how some of these new features may be used to improve the efficiency of your workflows, let us know. We'll see what we can do to help you out. Appreciate everybody for joining us, and you should receive an email at some point tomorrow that'll have the link to the recording of this webinar. So feel free to let us know if you've got any follow-up questions, and thanks for joining us.